Hello everyone, welcome to episode 9 of Remaking Cavestory in C++. This level is called This episode is called The Level Class Part 3. My name is Limeoats. My website is limeoats.com. My Twitter is @limeoats. This is my GitHub link where all the code and maps and everything are. And this is my subreddit. So let us begin by talking about the problem we need to solve in this episode. Now that we have our map built, we need our program to read it and understand it. It's in the form of a TMX file that we made Untitled. That's just a regular old XML file. We're going to go over it in a second because before the program understands it, we need to understand it. Otherwise, we can't write parsing code. So we're going to go over the entire TMX file, what everything means, before we start actually parsing it. Some details. Nothing really interesting here. We're going to parse the XML with the tinyXML library, which we downloaded in the last episode. So if you missed that, just go back to episode 8. Right near the end, we download the tinyXML library and get that all set up. Alright, so then how are we going to solve this? First, we're going to add SDL destroy render function to the graphics class. Thank you to Symbiotic, someone who commented on one of my videos, mentioning that I missed this. So we're going to go in there and add that. Then we are going to create a tile class to represent each individual tile we have on the screen. Then we're going to create a tile set structure in level.h, which is going to represent a tile set, which is the PRT cave, for example. So we're going to do that. Then we're going to add a few new variables to the level class that we're going to need, and then we're going to include tinyXML in level.cpp and implement the load map function, which is going to do all of the parsing of the TMX file. So, alright, before I do anything, I'm going to open up the TMX file in a text editor so that we can look at the XML and understand really what's going on there. So, close this. Let me open from here, go to git maps TMX. Alright, so yeah, that's about the right size. That should be big enough for you to see, hopefully. I'm not gonna make it any bigger. So anyway, this is the TMX file. So if you remember, if I bring tiled back over and open open up map1.tmx, this is where we left off last time. So when you save this file, yes, it saves as this, but what all this is an XML file, which is this. And then tiled, when you reopen the map, parses the XML itself and renders it like this. So anyway, I'm going to be switching back and forth for a bit between this and the XML to explain exactly what's going on here. So the first thing in the XML is this map node. And this has a version, which we're not going to worry about, an orientation, which we're also not going to worry about, and a render order, which we're not going to worry about. What we really care about here is width, height, tile width, and tile height. The width is the width of the map, so 20 tiles wide times whatever our tile height is our full size. Height is the same thing, 16 tiles high. So what that means is there are 20 tiles going across, 16 going down. Tile height and tile width is 16 and 16 because each tile here is 16 pixels by 16 pixels. Okay. So that's important. So we're going to be getting that information in a bit. Then it has the tile set, because inside the map there's a tile set, and there could be multiple tile sets. So if there were more than one that we loaded into this map, there would just be more than one tile set element. So there's only one because we're only using PRT cave for now. So we have our first GID equals 1. This is important. First GID. Let me explain what GID is for a second. If you look in tiled over here at our tile set, let me make everything else go away. So this is our tile set. Each one of these tiles is represented by a GID. So basically, I believe the very first one is GID number 1. Then it goes across and across and across and across all the way up to however many tiles we have here. And then, so first GID equals 1, that means that the very first GID in our tile set is represented by the number 1. If we had another tile set, the first GID might be like 60 if we had 59 other tiles in the first tile set. So since we only have 1, the first GID is 1. So that's going to be important. The name is PRT Cave. The tile width is 16 and the tile height is 16. We're going to need that for when we're cutting this tile set up in our code later. Then inside the tile set element, we have an image element. The source is the path to the tile set from the map in our project. So I'll go over that in a second, but if you go back to your project here, our map is here. So we have to go back one level, out of the maps folder, back one level into our root, back into content, then into tile sets, and then prtcave.png. And that's what we have here. Back one level, content, tile sets, prtcave.png. The width is 256 and the height is 80. That is the width and the height in pixels of our tile set. So we're going to need that as well. Then we have our layers. Now, if you remember from when we made this map, we have 2 layers. We have a tile layer and we have a background layer. So the name is background of this first layer. And our width is 20 and our height is 16. Then we have this data element, and then inside we have a ton of tile elements. And these tiles tell us which tile from this tile set is in each spot here on this map. And I think it goes across. Maybe this render order right down means that it goes from the top down. I don't really know. It's not really too important. What matters is that each one of these tile elements represents one 16 by 16 block here. And so the GID is whatever tile in the tile set is supposed to go in that spot. And with a ton of tiles, we end up getting all of our tiles here, coming from the tile set. Perfect. And then if we scroll down a little while, we get another layer, which is our tile layer 1, which has all of our blocks and stuff that's on that tile layer. Okay. A GID of 0 means there's nothing on that tile, which we're going to be actually writing special code for. So that's really all there is to a TMX file. It's a nicely laid out XML file representing our map data. So let's get started on actually implementing this. So before I actually code anything, let's just start our program. Just remember where we left off. This is where we left off. We have the background in the back, and we have quote running around, animated, all nice. This isn't the right background for the first map. I thought it was, it's not. So we're just gonna end up not drawing this. We'll be able to add backgrounds in later on. But for now, we're just gonna stop drawing the background, and you'll see how we do that. So the first thing we have to do is add SDL destroy render to our destructor in graphics.cpp. So go there, source graphics.cpp, and right underneath destroy window, we're just going to call SDL destroy render. This will avoid memory leaks from having a pointer to an SDL render in memory. We don't want that to just be hanging there without being destroyed when it's done. So that's that. That's just cleaning up our code a bit. So thank you, Symbiotic, again for that suggestion. Next up, we're going to create a tile class to represent each of our tiles. So go to headers and make a new file called tile.h. Our regular old header guards. So class tile, public, private. We'll have an SDL texture tile set. So each tile comes from a tile set, obviously. So we're going to keep track of that with SDL texture tile set, a private variable, which means we need to forward declare SDL texture. And we're also going to need graphics, so we'll forward declare that as well. And then we're also going to include globals.h because we're going to make a private variable of vector2, which was our structure we created. It'll be called size. This is the size of the tile. Vector2 tile set position, so that's the position on the tile set that the tile is. And vector2 position, which is the position in the map the tile is. So tile set position is where on the tile set the tile is. Position is where on the map the tile is. That's going to be important when we're actually putting all of our tiles together. So now we'll have a default constructor, and then we'll have our regular constructor, which is going to take in all of this stuff for our private variables. So tile set, size, tile set position, position. We'll implement that later. We'll have a void update, which we're not really going to use just yet, but we're going to end up wanting to update our tiles for collision and stuff. So we'll add that in now. And draw, passing in our graphics like usual. So then you can go to source and make a tile.cpp so we can implement all of this. Now tile.cpp is probably exactly what you're thinking. It's not really any different from anything we've written so far. You'll see what I mean in a second. So include tiles.h, include globals.h, include graphics.h. We actually don't need to include globals.h because we are already including it in the header file. And include SDL2/SDL.h. Our default constructor we're not implementing yet. Our regular constructor we are. Just all of our parameters. So we're going to initialize tile set to tile set, size to size, tile set position to tile set position, and of course position to a new vector2 where we are passing in position.x times sprite scale, position.y times sprite scale. Because don't forget, we're still, all of our tiles are going to be times 2 in size as well. They're all going to be double sized. We have errors. That's because of this. Okay. Then our update, which I told you we're not implementing yet. And then, of course, our draw, which is going to look a lot like the sprite draw, but tiles aren't sprites, so they need its own function. So SDL rect desrect equals position.x position.y size.x times sprite scale again. Size.y times sprite scale. Just like our sprite. I mean, I guess I could call it tile scale, but it's the same exact scale, so I'm just going to leave it with sprite scale. It's okay. Then source rect. The reason I'm going kind of fast through all this is because this is the same code that we have pretty much from our sprite class. And then just our sizes. Okay, so that's where we're getting it from on the tile set, source rect. And that's just like how we got it from the sprite sheet for sprites. It's the same thing. And then graphics.blit surface. I don't know what this is. Graphics.blit surface, tile set, source rect, and des rect. Glit surface, no, blit surface. Okay, and that's it. That is our tile class. Good. So the next thing we have to do is create a tile set struct, and this is really simple. This is to represent a tile set. So go to level.h, and down at the bottom, underneath the class, we're going to make a tile set structure. So struct tile set, and structures are by default public. They have public variables and functions, unless you put a private or protected or something. It's by default public. So we want that. We want them to be public just to make it easy. So SDL texture int first gid. So the texture is the tile set image. The first gid, as I explained before, the first gid on that tile set. Then we'll have a default constructor here, which is going to set first gid equal to -1. And we'll have our regular tile set, our regular constructor, taking in a texture and a first gid. And of course, just setting texture equal to texture and first gid equal to first gid. No big surprises there. And now we have our tile set structure. So now, what does this mean? This means we can add some new variables to the level class. So the first thing I'm going to do is underneath background texture, actually above background texture, underneath vector2 size, I'm going to add another vector2 for tile size, and that's just, of course, the tile size on the map. Our maps are all going to have the same tile size throughout each individual map, so we could just have one vector2 representing that. Then underneath background texture, we're going to add 3 lists. The first is going to be std vector of tiles called tile list. Then we're going to have an std vector of tile sets, which is going to be called tile sets, and those are all the tile sets we have on the map. This, of course, our tile list is a list of all tiles we have on the map. And finally, a vector of SDL rect called, actually, we don't need to implement that yet. It's going to be collision rectangles. We're going to deal with that in the next episode, so let's not confuse ourselves by adding any collision stuff just yet. So this is all we need. So now let's just go up to the top and include a few things. We need to include tile.h. We need to include vector. We need to forward declare SDL rect and we need to forward declare tileset. The reason we're forward declaring tileset is because we're implementing it down below the class, and so when this class is compiled, it has no idea what this is yet. So we need to forward declare it. That's fine. And that's it. So now for the main part of this episode, the hard part, but the most important part. This is writing this load map function is going to be extremely probably confusing for you. So if you have any questions, please contact me. I will be happy to explain it better. I'm going to try to explain it as best as I can right now, but some of the code even confuses me, and I wrote it because it's fairly complex. Some of the algorithms we use to loop through this stuff and figure out where to place each tile is kind of complex and a bit cryptic. It makes sense if you think about it long enough, so I'm going to try to explain it to you as best as I can right now, but obviously I wrote it so I can figure it out. If you ask me questions, I can just go through each line and help you. So please ask if you have any questions. For right now, since this was temporary code to load the background, we're not using it anymore. So go ahead and delete that. Okay. So at the top of our level.cpp, we need to include a few more things. We need to include, well, first we need to include tinyxml2.h. That shouldn't give you any errors after last time, so it's just in your header folder. It should be just like any other header file you have. And then we need to include ssstream for string stream. Include algorithm, which we're not using this episode, we'll use it next episode, so just include it now so we don't forget. And same thing with cmath. We don't need it yet, but we're going to use it in the very next episode, so just include it now. Now, finally, I usually don't like the using keyword in C++. We are going to write using namespace tinyxml2. All of the tinyxml2 stuff is in a namespace called tinyxml2. As you can see, I always write std and then the scoping operator for string and stuff. Instead of writing using namespace std at the top of all my files, I like doing it this way so that we don't have any name pollution or any of that stuff. But we're going to be using so many things here for tinyxml2, I just don't want to write out tinyxml2 : every time. So it's fine, it's all in one file, not a big deal. So using namespace tinyxml2 will let us use all of these variables and functions and stuff. So now, in your load map function, we are going to start. So I'm going to put a comment here saying parse the tmx file. So we are parsing the XML file. We are getting all of our tiles and tile sets figured out, all our tiles stored into a vector so that we can then draw them every frame. So the first thing we're going to do is an XML document doc variable. The XML document is part of tinyxml2. This just represents the entire XML document. Then we need to get the name of the TMX file. A lot of these functions are, I think actually this entire tinyxml library is written in C, not C++. So it doesn't use strings, it uses character arrays. I like to call them char star. I know it's character char star. I call it char star, so bear with me when I do that. But this thing, char star. Yeah. So yeah, we have to convert a lot of things into C strings for that reason. So let's start with an std string stream ss. Then we need the path to our map. So we have content. Well, actually, we don't have content because my maps aren't in content folder. We have maps / and the quotes If your maps are in the content folder, you'll need something like this. Mine are not, so I have that. Then we do this, we do this operator, and then we put in our map name, which is what we passed into load map.tmx. So that just builds a nice string with our map name. So if we pass in map1, for example, we get maps map1.tmx. That's how it comes out. So we're going to say doc, which is our XML document, .load file, passing in ss.str, which converts our string to a string, and then a string function called c_str, which converts our string to a C string, which is what this wants. It wants a const char star file name, so that's how we have to get to it from a string stream. Okay. Now we are going to start parsing the file. Now that we have the document open, we're going to start parsing it. So the very first element we have, we don't care about this XML element at the top, ignore that. We want the map element. So to get the map element, we say XML element pointer map node equals doc.firstChildElement map. So doc is the root of our XML document. So the first child element from the root called map is this, and that's what we're selecting. So now we want to get the width and the height of the whole map and store it in our size variable. So we're just going to make temporary variables int width, int height. And now we need to, whoops, I meant that. Okay, and now we need to get this width and height out of here. So it's an attribute of our map. It's an int attribute, and in the TinyXML library there's a function called query int attribute. And you give it the name that you want of the attribute, and you give it somewhere to store the variable, store the data, into a variable, and it will give you the number. And it looks like this. Map node, which right now is our map node, query int attribute, width, and we're going to pass it a reference to our width variable, and it will fill it up with the value of the width attribute in the map element. So 20 will end up in our temporary variable width. Same exact thing for height, switching the word width with height and using our height variable. And then all we need to do is set our size variable equal to this. So size equals a new vector2 with width and height. And that's it. We now have the size of our map. Okay? So then the next thing we need to do is get the width and the height of the tiles and store it in our tile size variable. Okay. So same exact thing as above, tile width, tile height, map node, query int attribute, tile width, and as you can see here, we just have, it's the same thing, we just have two more attributes called tile width and tile height, so we're just getting those. Okay. And then we are just going to store this in our tile size variable, the same way we did above. Alright. So now we got the size of our map and the size of our tiles parsed out of our TMX file. So next up we have to load the tile sets. So again, we could have multiple tile sets, but we need some of this data. And then we're actually going to load the actual tile set from memory, or from the image, the PNG image of our tile set. We're going to load it. So what's important here? First get is important, tile width, tile height are important, and the image source width and height are all important. So we're going to get all of that stuff. So let's start. XML element, pointer, P tile set. I'm going to start all of our elements with the P letter, and then the name of whatever it is we're trying to get. So we're getting tile sets right now. Equals map node first child element called tile set. So this will get the first child element called tile set. Now, as I said before, it'll grab the very first one. If there are more tile sets, though, that's going to be a problem because it's only going to do this once. So we have a way around that. If you know, if you ever dealt with linked lists, implemented them yourself, you'll know kind of what I'm doing here. But I'll try to explain it as best as I can. First thing we're going to do is, since it's a pointer, if there are no tile sets, that's weird, but we don't want our whole program to crash. So if tile set does not equal null, we're not going to try to access anything if it's null. But if it's not null, great. We're going to say while p tile set. P tile set, this equation right here, this while p tile set, will be true as long as this works. We're going to say p tile set equals p tile set next sibling element tile set. So I'm setting the pointer of our tile set pointer right here, equal to the next sibling called tile set. So if there's another tile set here like this, assume this was a whole different picture, a whole different tile set. The first time around we'll do our parsing, and then at the very end it's going to try to set our tile set equal to the next sibling of this tile set called tile set. So this right here is the next sibling called tile set. So then we'll do the processing of this. Since there's only one, what's going to happen is it's going to get to the end, it's going to try to set it equal to the next sibling called tile set. There isn't one, so it's just going to move on to the next part of the code. Hopefully that was explained well. So that's how we get all of the tile sets. And we're going to use that trick a lot for when we have all of these tiles. We're going to be getting the next sibling called tile. Same thing for data, same thing for layer. So make sure you understand why we're doing that, or this might be confusing. Okay, so the first thing we're going to do is temporary variable called firstGid. Now we need to get the source of the tile set image. So we're going to say const char star source equals p tile set first child element called image. See, the first child element of tile set called image is this right here. And then from there we want to get that image's attribute called source, and it returns a const char star, so that's why we're setting it equal to a const char star. And that will get us this string right here, stored in our source variable. Then we're going to make a temporary variable called path, because we need to take this path here and actually interesting. I'm confusing myself. Well, let's just keep going. We're going to make a string stream ss content tile sets source p tile set query int attribute. We're going to get the first GID off of our tile set, which is this one here. So first GID, and pass in a reference to first GID. Then we're going to create the texture from our image. So we're going to say SDL texture, I'll say text equals SDL create texture from surface, graphics.getRenderer, graphics.loadImage, ss.str. ss again was our path to our image. Pass it in as a string. Good. We have our texture. So what we're going to do now is we're going to create a tile set variable and add it to our list of tile sets. So tilesets.pushback, so our vector, pushback, new tile set, taking in text and first GID. That was our constructor we made. Takes the texture and an int for first GID. And then what will happen is if there's more than one tile set, it will loop on to the next one. Okay? Good, we now loaded our tile set. So now for the crazy part, loading all the tiles. So first we're going to load the layers. That's the first part of this. So if we look, we have a layer, then we have data, and then we have tile. If we have more than one layer, we'll have a whole new set of data tile on the next layer. So we need to loop through all of this. So obviously there can be more than one layer, so we have to do our trick from above. So I'll say XML element p layer equals map node first child element layer. If p layer does not equal null, while p layer, and I'm going to, right from the start, set p layer equals p layer next sibling element layer. So that'll loop through all the layers. Wonderful. So there's nothing really interesting going on in layer except for data, so that means we need to jump right to data. So I'll make a comment here, loading the data element. XML element p data equals p layer first child element data. So again, there can be more than one data element. So I'm going to say if p data does not equal null, while p data, this is the same exact trick where you're doing over and over and over. So as you can guess, we're going to say p data equals p data next sibling, next sibling element data. And then one more layer of this down to the tile. So loading the tile element. XML element p tile equals p data first child element called tile. So now we have, now it's time to parse our data, our tiles rather. So let me just open this up really quick. Alright, so the very first thing we're going to do here is, of course, loop through all of our tiles like we have been doing for everything. So if p tile does not equal null, before our while loop though, I'm going to make a new variable here, int tile counter equals 0. That's going to be important because we need to know what tile we're on in our whole entire loop of looping through everything. So we're going to keep track of what tile we're on. While p tile, and then of course p tile equals p tile next sibling element called tile. Okay, it is now time to figure out what all these GIDs mean and build our actual tile. So we're going to put a comment here. Build each individual tile here. If GID is 0, no tile should be drawn. I mentioned that before. If the GID comes up as 0, there should be nothing drawn on that tile in our map. So continue loop. So if p tile int attribute GID equals 0, that means no tile should be drawn. So of course we still did go through a tile, so tile counter plus plus. But just because we're not drawing that tile doesn't mean we don't want to draw any more. So we still need to go on to the next one. So we can't just break right here or continue. I mean, we need to actually figure out if there are any more GIDs. So if p tile next sibling element tile, p tile equals p tile next sibling element. We're doing this here because if it's a 0, it'll never make it down to here to actually move on to the next one, because we're writing continue. Continue will just make it go right back up to this while loop and go on to the next tile. If there are no more tiles, we're going to break out of the entire loop. That means that we're at the last tile, there's nothing left, time to move on. Okay? So that's if it's 0. If it's not 0, we have to do other stuff. So first thing, get the tile set for this specific GID. In our current map, we only have one tile set, which makes things easy. However, that won't always be the case. So we still need to put in logic here, just in case we have other tile sets later on that the GIDs are referring to. So int GID equals p tile int attribute GID. Just get our GID from there. Tile set TLS. Now we're going to loop through all of our tile sets we have stored. Right now we only have one, but we'll loop through all of them. Regular for loop through our vector. If tile sets at I dot first GID is less than or equal to our GID, that means that's the one we want. The very first GID on a tile set is the lowest GID we could possibly have. So if it's lower than the GID we're at, then that means that it's the one we want, because then the next tile set it would be higher. Okay, so that's definitely the GID we want. I have an error here. I is less than size. I plus plus if. I'm not seeing the error. Oh, that's why. Int I. Alright. So this means that this is the GID we want. This is the tile set we want. So we're going to say TLS equals tile sets at I. Grab the tile set, break out of the for loop, and move on. So that's how we figure out, that's our small little algorithm to figure out which tile set is associated with the GID we're dealing with right now. Then we're going to make sure our tile set isn't all screwed up. We have a default constructor for tile set. So if it wasn't able to find anything, we need to check that. So if TLS.firstGID is -1, that's because we set that in our default constructor, which gets called right here. no tile set was found for this gid. Tile counter plus plus, because we still went through a tile regardless, and the same thing again. If there's another tile element afterwards, move on to it. Otherwise, break out of this loop. That means we're done. Okay? So, moving on. Now this is where it gets confusing. So far all we've done is collect the tile set associated to the gid based on the first gid of the tile set. Now though, we need to figure out the position of the tile in the level. This is where I expect people to start getting confused, if they haven't already. So I'll try to explain this as best as I can. We need an X position and a Y position. Just because we have a lot of variables and everything, I'm going to call it XX and YY. Okay? So we're going to first try to figure out the X position of that the tile is in the level. So XX equals tile counter times width. So I'm just going to explain what this means. Tile counter is which gid we're on, which tells us which tile we're on in the in the map, and width times width. Oh wow, I'm sorry, not times width. This should be mod width. Mod width. So this tile counter mod width. Let's say for a second, let me open up this. So the very first tile on the map, we have 34. So tile counter would be 1. Width of the map is 20. 1 mod 20 is 1. So what that means is, well, all right. Still trying to figure out how to explain all this. Let me just XX times equals tile width. So 1 is the first spot, times tile width is 16. Alright, just kidding. 0 would be the first one. 0 mod 16 is 0, times tile width is still 0. So the first spot that we're going to put our very first tile is at 0 as an X position. Okay? The next time around, tile counter is 1. 1 mod 20 is 1, times 16 is 16. So it'll put our second tile, which is this one, at an X of 16, which would be right here, because it's 16 across from the beginning. And so on. And that just works. So that's good. The Y, YY plus equals tile height, which is 16, times tile counter divided by width. So let's figure this one out. Tile height, we know, is 16. So we started out at 0. Tile height, tile counter for the very first one would be 0 divided by 20, which is 0. Times tile height, still 0. So our YY would be 0. Let's say, though, that we're on this one. So that is 1, 2, 3, 4, 5, 6. Well, we know that there's 20 going across. So say our tile counter was at 20, because 0 through 19 are up here, number 20 is right here. So say our tile counter is at 20. Okay. So tile height, so we have 16 times 20 divided by 20, which is 1. 16 times 1 is 16. 0 plus 16 is 16. So it will draw this tile at a y of 16, which is right here, which is perfect. So this algorithm just gets us to the right spot on the tile, on the map. As you can see, again, I wrote this algorithm myself, and it's still confusing me. I have to really work through it to figure out what I did. But just rewatch that 1,000 times until it makes sense, because I did end up explaining it at the end there. So finally, we just create vector2 final tile position equals vector2 xx yy. And that's our tile position on the map. So now for an even more complicated algorithm, the last one though, calculate the position of the tile in the tile set. Alright, so we're going to start out with a int tsxx, which is for tile set xx, equals gid mod tile set width divided by tile set height. Tile set width divided by tile width minus 1. Why isn't tile set width a variable? That should have been made up here. Oh, no, I'm sorry. That we should make before we do this. So int tile set width, tile set height. And also up here, we're going to query our tile set texture to get its width and its height. So SDL query texture, we could pass in a texture, so tls.texture. The parameters here for query texture, let me open it up. Query texture takes in a texture, a format, an access, a width and a height. We don't care about format or access. All we care about is width and height. So we'll just pass in null for the first two there. And then we're going to pass in a reference to our tile set width and a reference to our tile set height. And so the width and the height of the tile set will be stored in these variables. Whoops. Okay, so they're stored in there. So now for our algorithm, tsxx times equals tile width. Okay, so let's figure this out first. So we need to know where in our tile set we're drawing from based on our gid alone. So let's look at our first gid. We have 34 as our very first tile being drawn. If we look into tiled, that's this spot right here. So we need to somehow get 34. We need to see how 34 relates to our tile set over here. So let's run through our algorithm. and figure that out. So gid, so 34 mod. So what's tile set width divided by tile set height? We know from our file that tile set width is 256. Tile width is 16. So what's 256 divided by 16? Let's go all the way over here. 256 divided by 16. Oh, come on. 256 divided by 16 is, why won't this work? Oh, because it is 16. Okay. Right. So 256 divided by 16 is 16. So 34 mod 16 is 2. Minus 1 is 1. 1 times tile width is 16. So how does 16 relate to this? $16 relates to this because we start at our 16 pixels over from the left, which it would be this second row here starts at an x of 16. As we know, this is the tile we're trying to get to. So our algorithm right there does work. It brings us to this this column in our tile set. So that means that next we need to somehow get to a y of 32. 0, 16, 32, so that our coordinates for this particular tile here are 16, 32. So we need to get a y of 32. So let's write out the second part of our algorithm to do that. So I'm going to say int tsyy equals 0. We're going to start it out at 0. Then int amount equals gid divided by tile set width divided by tile set height. Tile width, I'm sorry. I don't know why I keep saying that. So again, amount right here would be 34 divided by 16, which is, it's a fraction, 2.125. Since it's an integer, it's going to do integer division, and I believe we'll come out with 2. So from there, we're going to say tsyy equals tile height times amount. So 2 times 16 is 32. And so what we end up with is our 16, 32 to represent this particular tile. So again, a very crazy algorithm, but if you stare at it long enough and work through it with a bunch of different ones based on the gid and where they are in this tile set, you'll see it works out every time. And you'll see it works out every time when I run the program in a couple minutes, and it works. So a very confusing algorithm, but it works. It's the only way to really figure it out based on the gid. So make sure you study that. Again, ask me many questions. Make sure you understand that completely. We're just going to put our final tile set position equals vector 2 tsxx times tile width, not times tile width, tsyy. Perfect. And that is our tile set position. And that's all we need. We're finally done. So now I just have to build the actual tile and add it to the levels tile list. So tile, tls.texture, vector 2, tile width, tile height, and this is just our constructor for our tile. Final tile set position, final tile position. And then this tile list push back tile counter plus plus. And then it'll go through all of our GIDs, all of our tile objects, elements, create tiles for them, add them to the list, and we end up having our entire level in tiles. So now what we're going to do is we're going to get rid of all of this drawing background stuff. We're going to re-implement the background using tiled in a future episode. But for now, we're going to loop through tile list.size, loop through our tile list, and just draw them all. So loop through all of our tiles and draw them using our tiles draw function. And we're done. We are finally done. Compile. It actually compiles on the first try. That's incredible. Any missed pointer or anything weird in here will cause you very ugly errors, runtime errors, not compiler errors necessarily. Your program will just crash. So if that's happening, let me know. Read this code very carefully. Maybe take my level.cpp from the GitHub and use it instead, because there's no typos. Let's run it, see what happens. And we see that we have a black background. That's interesting. Why do we have a black background, you ask? I don't know. So this is the fun part of the episode where I have to do debugging because I wasn't expecting this to happen. The first problem might be that I have map1 instead of, with a lowercase m instead of a capital M. So let's save that and run it again. Still a black background. This episode's already extremely long, so I apologize, but I need to figure this out. Level.cpp. We're calling load map. Let me put a print statement in here just to see if any of this is getting called. Printf, hi, run it. Alright, it's getting called, so the problem is actually, let's look at our, this. So, dot goes back a level, /content. So our map is in our maps folder. Back one level is our root, then we go to content, tile sets, PRTK. So that's fine. So what could the problem be? I wish I had an answer to that. Let me comment this code out for a second. This is the code that skips some stuff. No, still a black background. Alright. What did I mess up? I messed something up. Somewhere along the way we're missing like one little thing. Well, one thing to look at is this. Let me get rid of this. Let's see if we crash. Oh, there we go. All right. So what happened was, for some strange reason, if you remember a while ago when I was writing this code, I stared at this for a little while and I was confusing myself. I don't know why I put this in here, but we ended up building the path to the level as content/tilesets/content/tilesets/prtcave.png. That's obviously wrong. It already, if we look at the file, it already has this entire path. So we don't have to add on content/tilesets. So go ahead and get rid of that. We still need to pass into the string stream so that we could get it into a string from what it is, from the char star. So yeah, save that, run the code, and we have our entire level. Yay. That's everything we added into tiled, all drawn to the screen very nicely. Yeah, no collision, none of that yet, no gravity. But every tile we have there is now drawn in the correct spot. The background is back here, the black. All the other backgrounds, the tiles, they're all here. The door. Perfect, it works. So that's all coming directly from this ugly TMX file. I shouldn't call it ugly. It's actually very, very well written. It has all the important information. It's just a matter of turning this GID into a position on a tile set, which is not always easy. So anyway, this episode's already way too long, so let me just quickly talk about next time. Fun stuff next time. Next time is an exciting episode. We have gravity, we have collision, and we have a spawn point for the player. So we're already kind of implementing the spawn point, but we're going to change it. We're going to actually add it through tiled so that we can see it in our, while we're building our map, where the player is going to spawn. We have collision, which is also going to be through tiled. We're going to draw rectangles around our collision spots. And gravity, we're just going to add some gravity to the player. It might not be our final implementation of gravity, but for now it's going to be good enough. And that also means we'll be able to jump around and stuff. We'll add jumping too, so I'll add jumping to the list. I'll add jumping at the end though, because there's no point in jumping without collision. I'll actually add jumping after collision. Alright, I'm going to end this episode. Thank you all very much for watching. Again, I'm Limeoats. My website's limeoats.com. My Twitter is @limeoats. If you have any questions, which you probably do after this episode, I understand. Post them on this subreddit and then tweet at me saying, Limeoats, answer my questions. And I'll go there and I'll answer everything you have. All this code is on GitHub, including the map. So go here to get it, or to look at it, or to do whatever you want with it. And I will see you all next time for this exciting last part of our level class episode. So thank you all for watching.